the cool thing about these is they're related to each other. Okay? Multiplication is actually a shortcut for us. It's actually a shortcut, or an abbreviation, if you like. So I'd like you to write down, underneath your table, I'd like you to write down this sentence. Multiplication is an abbreviation. That's a long word. Let's spell it out, shall we? A-B-B-R-E-V-I-A-T-I-O-N. Multiplication is an abbreviation. The question is, what is it an abbreviation of? Now, we usually use abbreviations in language, don't we? Instead of saying I am, we say I am. Okay? So you save a whole syllable. Woohoo, okay? So you're taking something long and you're writing it into short form. But everyone knows when you hear someone say I'm, they know that you mean I am, right? But we have other kinds of abbreviations. Some special abbreviations are called acronyms because each letter stands for a whole word, right? Because Cherryville Technology High School is a bit of a mouthful and it takes a long time to type as well. So that's why we use abbreviations. Okay. What's multiplying? What is it abbreviating? What is it shortening? Now, we're going to finish this sentence, okay? So leave some space there. On the next line here, right? Help me out here. 5 times 6, that's a little big. I'm going to do 5 times 3. 5 times 3. Okay. What's that short for? Saw a few hands up before. Morgan, can you tell me, what is 5 times 3? If I write it out, not just the actual number, what's it short for? 5 times 3.
5 multiplied by 3?
Yes, that is. So we've got the language, it's expanding there. But what does that mean? Can anyone help them out? Yeah, no.
Oh no, it's like 5 groups of 3.
5 groups of 3. Okay, which is kind of why we say times. Now, I can write 5 groups of 3. Watch, I'll write them. Here's one, and here's another one, and I guess I need another one, and another one, and another one. Okay, I'm done. There's my 5 groups of 3. Okay, this is what 5 times 3 means. There are 3s, and I've got 5 of them. Okay, but this is long and a pain to write and very repetitive, and you know what this is going to be, just like you know what these are going to be. Okay, which is why we write them in this short form. Okay, so what's multiplication an abbreviation of? It's an abbreviation of addition, isn't it? If you want to add lots and lots of things that are the same, you can use multiplication instead. It's much more efficient. Okay? Mathematicians, if you haven't already learned, you will learn in the next 6 years. Mathematicians are notoriously lazy people, which sounds unusual. You're like, maths is hard work. Actually, mathematicians are always looking for shortcuts for how to do things. There are whole branches of maths about how to take long things and make them short. Okay, so it's an abbreviation of addition. Now, I'm going to keep exploring this idea here. 5 times 3, that's how I write it. Okay, how about 3 times 5? What's 3 times 5? Now, how would I write it? Before you tell me the answer, how would I write it?
5 plus 5 plus 5.
Good. Now, it is a bit shorter than the previous one, but still long. Okay. Now, here's the important thing I want us to see. Okay. You've all been wanting to tell me this for a long time. What is it actually equal to? The first one? It's equal to 15. What's the second one equal to? Also 15. Okay. Now, what you're seeing is that the order here, when we switch it around, it doesn't change the final answer. It does change what it looks like in the middle, but you get the same result, the same product at the end. Okay. Now, this is a really important property. We give it a name because it's so important. Has anyone heard the name? It starts with a C. It's another long word like all of these. Anyone see it? Any takers? It's, yeah.
Calculation.
Ooh, now these are all calculations, and that is a good long word that starts with C. But I'm looking for something a little more specific. I'll give you the word because it is a bit unusual. Here's the sentence I'd like you to write underneath this. Okay? Multiplication is, and we'll put this next word in either in capitals, or if you've got another colour, you can do that. I've got another colour, and I'm going to do it in capitals because it's so important. Multiplication is what we call commutative. Okay? Whoa, that's a weird word. Commutative. Which means that if you switch the numbers around, if you do them in a different order, 5 times 3, 3 times 5, the order doesn't change the answer. The order of the numbers. Okay, now that's a really important idea to get. By the way, commutative, we have another word that is very, very similar to that. Maybe your parents do this if they work in the city. Does anyone know the other English word that's very similar to this? It's actually almost there in its entirety. This word here, when you stick an E on the end, commute, right? Do any of your parents talk about commuting? Commuting? It's about changing location. So they say, I have to commute to work. I have to go into the city and I have to commute by train or commute by bus, right? And you see there's a relationship there. It's about changing a position, right? That's what commuting is. It's like you're going to commute from here to there. And it's the same thing with these numbers. They're kind of commuting, if you like, and it doesn't change the answer. Okay? Now, multiplication is commute. So I might put a little, wrong color, a little C here, not for copyright, but for commutative. Multiplication is not the only commutative operation. There's another one. Which one is the other one where you can change the order and it doesn't matter? Yeah.
Addition.
It's addition, isn't it? This one's also commutative because, you know, all of these threes, okay, they're the same. That's a bit boring, isn't it? But if we were to do an example over here, 3 plus 4 is the same as 4 plus 3. I can muck around with the order, no problems, it's still 7. Okay? Subtraction and division. Can you see why they are not commutative, right? We were thinking about subtraction yesterday, weren't we? Okay, so for instance, if you do 5 minus 3, what's that equal to, just quickly?
2.
That's 2. But if we switch them around and change the order, which I heard we did a bit of during your homework yesterday, that's equal to not 2, it's equal to negative 2. Okay, so the answer is not the same when you switch it around, right? And division, we'll get to him a little later, but also the order really matters. Okay. Okay, so multiplication is commutative. Maybe you can put addition as well. Okay. Now, let me just quickly illustrate this for you. I'm going to go with my 5 times 3 and 3 times 5. Okay. How can we draw this? 3 plus 3 plus 3 plus 3 plus 3. Well, I suppose you could view it like this. Let's do it like so. I've got a block of 3. There's a group of 3. Okay. Now I want 5 of them, don't I? So I'll put another one here, another one here, another one here, and there's my last one. If we count them up, we go ahead and do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's a relief. Okay. You always want to make sure that you get your right answer at the end. So that is 5 times 3. 5 lots of 3. Okay. How would I draw it differently to demonstrate this? How could I do it? How many do I have here? Across the top, I've got 5, don't I? So what I'm going to do instead is to draw across like so, right? And there's going to be 5. 1, 2, 3, 4, 5. There's one group of 5. And here's another one. And here's my last one. Okay. So maybe you want to draw that in different colors as well so you can distinguish them. There's my same 2 equations, if you like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? And that's 3 lots of 5. 3 times 5. 3 multiplied by 5. Okay? And if you like, really these are 2 ways of looking at the same thing, aren't they? If I were to take a grid, how do I draw it? Sorry, it's a bit too tall, isn't it? It's kind of like taking this grid and slicing it up different ways. Slice it up vertically, slice it horizontally. Same grid. Question. Oh, you sure?
Yeah.
Okay. So this grid, I can chop it up one way, or I can chop it up another way, but it's still the same grid, right? It's just like if you had a block of chocolate and you divide it up into rows or you divide it up into columns, you're still going to have the same block. Breaking it up in a different way doesn't magically give you more chocolate, which is unfortunate, but you know, that's reality.